Welcome back, guys. Solving radical expressions, part 4. So we're basically continuing the process we did yesterday and last week. Like I said, I want to get everyone on the same page, feeling good about these process. All right. So first example for our notes, 3 over x minus 3 equals 3 plus 1 over x minus 3. All right, so we got, it looks like a little binomial. X minus 3 is the only denominator we see. We're going to multiply everything times x minus 3. All right, let's multiply it out, see what cancels. X minus 3 cancels x minus 3. What's left is a 3. And that equals, so nothing there, so 3, nothing to cancel for this one. So just multiply there. And then x3 cancels, so it's just plus 1. All right, so let's now distribute, get rid of the parentheses. 3 equals 3 times x, 3x. 3 times minus 3 is minus 9 plus 1. Let's combine like terms. 3 equals 3x minus 8. Let's add 8 to both sides. So we got 11 equals 3x. Last bit of our stage here. Divide both sides by 3. So x equals 11 over 3. Excellent job. As usual, just let me know if you guys have any questions. All right, we got 1 over n minus 1 equals 2 over n minus 1 minus 1 over 2 times n plus 3. Oh, we got little differences here. Okay. Oh, why did I put that? Don't need parentheses there. All right, so we got 2 different pieces, right? So whenever you have 2 different ones and none of them, we can't do a GCF for any of the pieces because we can't factor anything out of there or those 2. So easiest answer, multiply both of them together, and that's what we're going to use. So n minus 1, 2n plus 3. We're going to multiply all of them by that mess, right? So this one up here, you have n minus 1, 2n plus 3. Sorry, and this one, multiplying the same thing, n minus 1 times 2n plus 3. All right, so multiply them out, get rid of those fractions. Cancel there, what's there, what's left? 2n plus 3 times 1, or just 2n plus 3. N minus 1 cancels there, so we got left is 2 times 2n plus 3. 2n plus 3 cancels there and there, so we got left is a minus 1 times n minus 1. Let's get rid of those parentheses. 2 times 2n is 4n. 2 times 3 is plus 6. Minus 1 times n is minus n. Minus 1 times minus 1 is plus 1. And then let's combine like terms. 2n plus 3. 4n minus n gives me 3n. Then plus 6 plus 1 plus 7. All right, start moving things around. 3 minus 2n to both sides. So we got 3 equals n plus 7. And do minus 7 to both sides. So that's there. So you got 3 minus 7 is minus 4 equal to n, or n equals minus 4. Excellent. Okay, so anything else we need to do? I think we're doing all right there. All right, then so we got plus 3. Pieces looking good. All right, let's go on next piece. Sorry about that. Just was double checking my pieces. All right, so we got 2 plus 1 over r minus 3 equals r plus 2 over r minus 3. All right. And then it looks like, well, only denominator C is r minus 3. So I'm going to multiply everything times r minus 3. Okay, so we got 2 times r minus 3 there. R 3, cancel. So just plus 1. R minus 3, cancel. And that's just r plus 2 left. Let's get rid of that denominator, or the parentheses here. So 2 times r is 2r. 2 times minus 3 is minus 6. Plus 1. Let's combine like terms. 2r minus 5. R plus 2. There's that wonderful time where you can basically move anything you like. Move the minus r across, cancel there. So anyway, r minus 5 equal to 2. And then let's see, we're going to add 5 to both sides. Cancel there. So end result, r equals 2 plus 5 is 7. Excellent job. All right. Keep it looking, pause, rewind, whatever you need, guys. All right. 2 over n plus 4n plus 4 over n. It's a 4. Sorry about that. Equals 1. Okay. I only see one denominator here, so it's not too bad, hopefully, because we're going to multiply everything times n. So n times n will cancel there. We got left is the 2. N and n cancel, cancel. What we got left is the top is 4n plus 4. And 1 times n is just n. Let's combine like terms. So only one thing there, so 4n. 2 plus 4 is plus 6. N. And let's see, we're going to do minus 4n to both sides. So 6 equal to minus 3n. Last little bit, divide by minus 3 to both sides. Cancels there. So 6 divided by minus 3. We got minus 2 equal to n. Excellent job. Okay. One more example. 1 over k squared plus 2k equals 1 over k plus 2 minus 3 over minus there, k squared plus 2k. Okay, so look at these pieces here. Well, we got different denominators here, different pieces. Sorry, that's supposed to be a plus 2. All right, so we could pull out GCFYs. So between these two terms, k will pull out of both. So k plus 2. Nothing will compile there because they're the same, but it does match there on the right, on the left there. Here on the far right, it's going to be the same. So it looks like the common denominator to utilize is k times k plus 2. So multiply everything times k plus 2. K times k plus 2 times k plus 2. All right, so on the far left here, k cancels that k plus 2 cancels that k plus 2. All you left is that 1 that's up top. So 1 equals k plus 2 cancels k plus 2. So this k times 1 is k. And that whole thing cancels that whole thing. So what's left is the minus 3. Oh, nice. Came down to a nice little piece at the end there. So it's going to add 3 to both sides. 4 equals k. There we go. Or if you like, you could write it out as k equals 4. It's the same thing. Either way is cool. All right, good job, guys. Pause or run. Get the notes all good. Get them turned in. Let me know if you have any questions.